Now, Sam, the floor is all yours.
Thank you so much, Ellie, for the great introduction. And I recognize you completely as a co-manager of this open call, so props to you as well. So thank you everyone for being here. I'm going to take 5 minutes of your time just to briefly go through what the AI4Media project is about. Okay, it's a project that started back in 2020 for 4 years. So if my mathematics are correct, that means that we're going to close at the end of August. It's been a 4 year journey, a very successful journey, as you'll be able to see if you visit our project website. But what has AI4Media been all about? It's been focused on delivering top of the game AI research and training that, as you can see in this very simplified description, is at the service of media, society, and democracy. Okay. And we understand that AI is very particular in the sense that it requires a lot of ethical and trustworthy considerations. Okay, AI4Media has great value, but there is also risks that we fully recognize, and the project is there to understand the value that it has, but also be very keen on these ethical considerations that have to be kept in mind in the many, let's say, domains that it can be in which it can be applied. So if we move forward for just the next slide, how has all this been, say, delivered over these past 4 years? We have two main pillars, the first of which we want to be a center of excellence, or this is where we've been. This is the path we've taken and what we've effectively established. A center of excellence where we've aggregated so much knowledge, as you see, not only through the projects that we're going to have here today, the sub-granted projects, the 8 that are here today with us, the 10 that were with us in the first open call, but all of the work that the different almost 30 partners of AI4Media have come together, developing new research, new components, new data sets, information and content that is available, and likewise been made available to the broader network of researchers and people from the industry. So why the media, as the slide says? If we jump to the next one, because it is undeniable that the media is transversal to almost everything and anything that we use, interact with, consume on a day-to-day basis, whether that be information in its different formats, news and journalism, social media, entertainment, and arts and creativity. The media is everywhere. AI can be used in basically any of these contexts. So it's important to understand the value that it has, the risks that come with it, and be aware of all those pros and cons, and how it shapes the way that we, face our day-to-day activities. Okay, so if we jump to the next slide, what in fact did AI4Media, what do we have to offer? What have we worked on over the past 4 years, and what is the, let's say, the main contribution of the project to the wider community? Okay, so 6 main pillars here. We have the European Media AI Research Agenda and Observatory. So basically, it is a collection of research activities, other papers and work that looks into the current status quo of media and the AI and next steps forward in these domains. Research and innovation activities, so a specific set of areas that we wanted to focus on that we thought were, top of the game in terms of these domains. Then we took this research, we took this innovation, and this includes components or data sets, different research, and applied it into specific real world use cases with the very top leading also organizations that are also part of the project. We had naturally the equity free funding, or FSTP, the cascade funding, however you'd like, where we offered 1 million euros to 20 different entities, 8 of which are here today, and will present the work that they've delivered. Then we have the doctoral academy. We had different courses, the mobility of students across different European universities as well. So a very successful outcome over there. And we have the virtual center of excellence, which aggregates all of the great work that we've done and allows researchers and the industry to go there to make use of the different outputs that we've aggregated. So moving forward, just to wrap up some of the key achievements that we've accomplished over the past 4 years, more than 400 publications that have been done, 90 open software solutions, more than or approximately 40 data sets, 60 courses offered within the ADA doctoral school that was just mentioned, 480 resources that are available to use. And I made a mistake just a few seconds ago. There's 2 million euros in funding for 20 projects. This is a mistake on my part. That's 1 million euros in funding for the 20 projects. Okay, so very successful project in my opinion, and I extend my congrats to all the partners and to the 8 project beneficiaries here today for their excellent work as well, which I think is now where we're headed to for the next hour, where we're going to get to know the projects that were funded through AI4Media in the second open call. So thank you everyone for being here. I think I saw also Yanis and Filaretti, which are the coordinators of the project. So I know I'm going slightly off topic, but I would be okay with giving the floor 30 seconds to them if they want to add anything to this brief introduction before we move on. I'm sorry for putting you on the spot, but it's just an opportunity in case you'd like to say something about the great work that we've done in this project.
Yes, Samuel, thank you very much. Thank you for this nice overview. Nothing to add from my side. Just to mention that we were very happy with, and I hope also every participants were happy and satisfied with the overall management of the open call procedure, both the selection and the execution. And from our side, I think it was very useful, and there were interesting additions to the, let's say, ongoing work of the project, and very nice collaboration. So I think overall it was a very nice outcome in involving even more the community in the framework of the project.
Thank you, Yanis. Okay, I think I can hand the control back to Ellie, and let's get to know a bit more of our projects today.
Yes, thank you, Sam. Thank you, Yanis. Now, as I've mentioned, first we're going to start with the application track, more market and customer-oriented projects with specific solutions for the industry. Here, out of the 5 organizations that have participated in our program, we have 3 today with us that are going to present. And we will start with Magnet.
I'm going to share my screen.
I'm stop to share, and I think you can do it.
Sorry. Right to the Oh, you can see the full screen, right? Okay.
Yeah, perfect.
Okay. So, my name is Paul. Hello, everyone. I'm here on behalf of Windows Solutions, and I'm going to present to you Magnet. So, Magnet basically was an idea that we have about an application that would be able to understand what people are creating and provide them with related knowledge. Okay, so now I'm going to give you a spoiler alert about the end of this presentation. We failed. Okay, right, for us it was a failure. Plot twist, we are very happy with that result, and I'm going to explain to you what this means. For this, I'm going to start from the beginning. So, the beginning, we had an idea. Like everything we do, we work as knowledge workers, so we have ideas. And this idea went on to be spread with talks with other clients that gave us inputs, gave us other ideas, gave us refinements to our idea. And by the end of our last project, before we started with AI4Media, we had a project with a national organization that's the National Information Communication company in Portugal. They we had a very clear sketch of what we wanted to do. And the concept behind this was like this. How does our idea work? We had a concept where people would start inputting elements, trying, imagine a journalist writing a newspaper article, okay? He's writing a piece. Our application detects his context, detects his location, the expertise, detects the contents of what's being written, and based on that, grabs information, related knowledge items that will enrich this activity, and then provides it back with some information about the amount of relation that this has, the importance that it might be, and then the user selects or even corrects the software regarding this. So this was the basic idea behind Magnet. Our project, so this would be the end result of our application. So you can see the person started writing something. This is obviously an illustrated test. So the journalist started writing about tackling climate change. This is a collaborative item, so you can have more than one author. Then you can see attached items, attached people that might be useful, attached sources that might be interesting. This was the idea behind our application. The process in terms of AI4Media, so our project within AI4Media had a specification, it had a prototype and a testing stage. This was iterative. Then there was a validation stage. And here where all the bells started ringing, because what we thought the market wanted wasn't exactly what the market effectively wanted. Or at least people told us, this is a very nice and interesting idea. But then in the end, they weren't really ready to back that up with money. So that doesn't work. So we understood that what users were looking for was some kind of a clipping application which already exists, and something that would go behind paywalls, that would be like a Google without the prompts. So a mix between Google and ChatGPT that would give them information, digested information, which wasn't what our idea when we created Magnet. So this was a kick in our teeth. we were there a little bit surprised with what we should be doing, and stopped and sat and said, "What now? What are we going to do? We are going to put this aside," because this was quite a bit of investment of our part. We really believed in the application, and then there was a small light at the end of the tunnel, and the small light at the end of the tunnel was that someone approached us very short time after the end of this project, and started talking to us and telling us some requirements that they had for an application that they needed, and it was very much a continuation of what we have done until then, with Magnet, but for a different sector. We had envisaged in our business model to enlarge and widen our the sectors which we wanted to work, because we were looking for media as a first stage, but all knowledge workers may benefit from this idea. But this sector we weren't expecting to work with, because, well, we didn't consider this as a good idea. And then right now we are condemned to work with lawyers, which is a very good thing. I'm having this poster for a movie, but it's a very good thing because, well, there are lawyers. There's always the difficulty of having to work with lawyers, but on the other hand, they need something like this. They need to digest loads amounts of information when they are writing. They need to have some enrichment of their activities, and so we have an application which is basically an upgrade of what we have done in Magnet. This is why we failed, but we are very happy about the results, because our idea was to provide a meaningful application that would help knowledge workers to be able to enrich their work and have an easier access to information that surrounds them. We didn't get to do this for the media sector. We got to do this to the lawyers, to the law sector, which is the legal sector, which is very good, because on the other hand, they also have a little bit more money than most media, so this is also good for the business. Finally, I'm going to give you a side note, because this is also a result from the project, 2 or 3 weeks ago, my colleague Rui Neves da Silva, he was also here. I saw him coming now. He went to a conference in Madeira, present a paper, present a paper about what we did as an algorithm for our application. It wasn't our main target. We are not our main aim. We are not a scientific organization. We are a technological organization, but it's also a very welcoming and very interesting result. So I hope I didn't exceed my 5 minutes. Here is our end slide. Please get in touch with us if you want to know a little bit more about Magnet or about our work. Okay, thank you.
Thank you, Paulo. You did not exceed. It was an excellent presentation. I love the plot twist, and like for me, this is not a fail. Like it's excellent, and it's exactly what programs such as the AI4Media Open Call give, right? So you fail fast, relatively cheap, and then you pivot. So I think that's an excellent result. Thank you for this presentation. I hope that we're going to have very interesting questions at the end.
Thank you.
Thank you for that. And now we're moving to our second presenter, who are Mindbugs Discovery.
Yes, hello. Paul, could you please stop the share screen so I can share also mine?
It's still yes, now it's good. Thank you.
Okay. Can you see my screen? Yeah.
Yes, it's just not full screen, but I see the presentation. Yes, now it's excellent.
Hello, everyone. My name is Ioana, and today I'm going to present the Mindbugs Discovery project, which is empowering media with AI against disinformation. So when we talk about disinformation, there are a lot of challenges about it. The first is that it seems to be overwhelming, so it's chaotic from everywhere. And the people who are fighting it are in a lot of resource constraints and do work in isolation. Last but not least, there is quite a high price in understanding disinformation because it often requires programming support or programming skills yourself, and that for media specialists is hard to be accessible. Our mission is to connect media experts against disinformation in a trustable space, and we offer an advanced visual search engine built on top of verified fact-checking websites. During the AI4Media program, we created a hybrid pipeline which was deployed on AI4EU platform. That means that all of you can access it and use it. You can use any of the three components that we deployed in the pipeline, or you can use the pipeline as a whole. But I will talk more about what the pipeline does. So the first component is called the data broker and is responsible for collecting structured data. In this case, it has a statement and a label information. That is the disinformation claim and the label like war propaganda, disinformation, or fake news. Then we have the aggregator, which is training a classifier for categorizing the type of disinformation and also extracting relevant keywords from each of the disinformation statements. The last component is the knowledge graph. So all the text data inside the tool is in the form of a graph. So they are all connected. Now, when you input a statement, it does not only give you a label, but it also shows you a community of strong interconnected fake statements. And this community has different fake statements and different keywords. This will allow you to have a broader overview of what is happening inside that area. Our solution is overcoming the challenges of disinformation by providing a clearer understanding and a trustworthy community. Also, it boosts the disinformation fighting capacity of media organization with more cost-effective solutions because they are more general. Where are we now? So we deployed everything publicly. You can access it on our website. We improved a lot the search part, which is now a combination between keywords matching and cosine similarity to capture both the behind the story narrative, but also find some specific keywords. The cross-country comparison of disinformation narrative is available on our website. The analysis and frequency of the fake information. And the timeline, was very interesting for different specialists because it's very obvious how a narrative evolves and spreads all over Europe, starting from a certain key region. The last part that we worked on is a new way of exploring textual data inside the graph. So it's a new way of navigating text data through nodes and through connections. As in for the market validation, this year we participate in the IPI World Congress in Sarajevo 2024, where we tested the tool with over, I think it was 50 media specialists. Also, we participate in OW2Con in Paris, which was about open source because everything we do right now is open source and available for the broader community. And we have 2 collaborations with media experts from Europe, and you can find different case studies on disinformation narratives which were spread in Europe on our website. And right now we still have some leads, but I won't tell anything not to jinx it. We have a multidisciplinary team. Since AI4Media, we grew a little bit. We have UI UX designer, we have investigative journalist, and also a specialist on international politics. Thank you all, and I invite you all to get on our website, explore what we do, explore our tool, use cases, blogs, and if you feel that for your organization, big data visualization for text is helpful to understand patterns and narratives, not only on disinformation, but maybe on market trends, on opinions, and on surveys, get in touch with us. And yeah, thank you a lot.
Thank you, Ioana. Thank you for this presentation, and I'm very happy that your team is growing strong and you continue doing what you started in the AI4Media program. So thank you for that, and let's see what the questions are going to be. Now we're moving to the third and final project from the application track, which is Vireo.
Hi all, just let me share my screen.
Perfect.
Okay. So hi everyone, I'm George Raptis, and I'll present our project called Vireo on behalf of Humanopsys. So in news and media industry, professionals are facing everyday new challenges that they must address to maximize productivity and improve their services. The rise of alternative sources of media and news, such as social media, has created new demands in the industry, including the need to quickly publish across multiple platforms that include both textual and visual content. So for the authors, writing an article is the primary task. The secondary task here is to select images that can accompany the article. But this task can be time and effort consuming. So here is where our solution fits. We implemented Vireo, which aims to address this challenge by providing professionals with an integrated software tool that recommends images based on an article. To achieve this, we follow a 4-step process. The first step is to analyze images by using AI to generate text and embeddings that describe them. This step is scheduled to be performed in the background every time new images are imported to the database. Next, the author writes an article and Vero analyzes the article to a format that is understandable by the machine and compatible with the format of the generated embeddings of the previous step. This step is performed in real time. Likewise, Vero compares the given article with the images by assessing how much similar the AI-generated embeddings are. And the final step is to select the best fit images and recommend them to the author. So let me show you a couple of videos to demonstrate how Vero works. So the first video demonstrates the front-end tool. This is a tool that the author uses to write an article. The authors type their article, and when they finish, they can click on the recommend images button, and the tool recommends the best fit images. If the author is not happy with the suggested images, they can press the button and load more images. And finally, they select the image that they think that it's the best fit for their article. Now let's see what is happening on the background when the recommend images button is clicked. The backend tool runs image versus text comparisons, and this comparison generates a matching score. We follow a ranking process, meaning that the top 5 images each time are returned to the user. We can also see that there is a confidence score, which indicates how much confident the Vero AI tool is that the under-processed image describes the given article. So at the end of the project, Vero achieved a TRL level of near 7, meaning that the Vero prototype is demonstrated in an operational environment. In the last months, we have made progress toward TRL 8, and we have taken steps towards delivering Vero as a complete integrated software solution. Our recent work focuses on refining the AI models and integrating Vero in the work pipeline of news media professionals. And toward this goal, we have some active partnerships with regional agencies supporting their need for quickly finding images to describe the article they publish. Vero has been demonstrated, validated, and awarded in International Innovation Technology and Research Expos. Our project attracted interest not only from the news and media stakeholders, but also from public bodies, social media platforms, and content creation agencies. And this gave us, they gave us insights and new visions on how Vero could be extended and to fit their needs. And this actually leads to new market potential. A few words about the Vero team. Our core implementation team consisted of 4 HumanOps members, Christina Filio, Vasilis, and myself. And of course, we would also like to thank our success and AI4Media in general for making this journey a real thing, especially Ellie, Heja, Klaas, and Sven for the ongoing support and mentoring. If you want to know more about the Vero project and get updates, please visit our project website, vero.humanops.com. And that's from my side. Thank you.
Thank you, George. Well, now this was our last presentation from the application track, and we can actually move to the Q&A. I hope that you have prepared very interesting questions for our teams. George, can you just stop sharing the screen? Yeah. This is very tedious with Zoom every time. Like, can you stop sharing because I want to share now? So let me share now my screen. So those were our 3 projects, and as I've mentioned, we're moving to the Q&A session. We have a 10-minute slot for this, and I want to invite all of you to ask your questions. I see Yanis first.
Yes, thank you very much for the very interesting and informative presentations. I have a question for Ioana, whether she could share with us her experience with I saw the AI for EU Is it now the AI on demand platform? Let's say how it is very interesting. This is why I'm asking how they consider using this platform and what is the experience in terms of usability, functionalities, and so on.
Hello, Yanis. Thank you for your question. Yeah, actually, the challenge that we participated had, so it was about deploying a hybrid pipeline on AI on demand or for EU. I'm not sure, they keep changing the name, or for experiments. Yeah, so actually it was a bit hard because so it started like we started doing some tests, and then we realized that it takes a long time to build the Docker images for the platform. And then we bought a MacBook Pro M2 so it runs fast. And then it didn't work at all, but we had a lot of support from both Ali and from the people from the AI on demand platform, which realized that their platform did not support Docker images, which were built by Mac. So they fixed that. So I feel that that platform has a lot of potential. There are still some limits according to, I'm sorry for being so technical, I don't know how to say it more easily, to the protobuf files, so to how the components communicate with each other. But I really love the idea, which are they doing, and I hope it will be useful because the idea of reusing small components between everyone's work, it's really important for us also, since everything that we created both in and after the program AI4Media, it's open source, and we like to share with the community as much as possible. So it was a new way of sharing with the community, and I hope it would be useful for the people in the AI for Experiments platform.
Okay, thank you very much.
Thank you.
Thank you both. Other questions? I see one in the chat. I have a question for George from Vireo. What is the source of the images, and does their tool check potential copyright issues?
Yeah, this is actually our main problem, the licensing and the copyright issues with the images. At first, we focused on the news and media industry, but in real life, I mean, in practice, the news and media industry actually works with, let's say, photo agencies or agencies that provide such materials. So one of the next steps is actually to work with such organizations and put Vero in the pipeline of capturing images or uploading images in open repositories, or I mean repositories of image providers. The licensing issues are the ones that actually is I mean this is the next step in terms of applying Vero in practice. But in any case, the method works for all type of images, and regardless the license they have.
Thank you, George. I think you covered it all. Other questions? Sam?
I'll throw one out there if none of our other participants have anything to ask. So this is not targeted to anyone, but maybe I'll point the spotlight onto Paulo so he can jump in as well. So my very generic question to the application track projects, Paulo, Ioana, and George would be, how do you see all of the recent progress? And I'm speaking from a perspective of, not being as technically knowledgeable as you might be in terms of, progress developments in AI. Have you seen this as more of a challenge to your own innovation journey, or has it been more of a benefit to your projects? There's so much being developed that you can use, or is it the fact that so much is being developed that's an idea that I had that I can't explore. I'm just going to be overlapping. So if it's been a challenge, what have you done to kind of pivot? I mean, we have the case of Paulo and Rui who pivoted in a very interesting way. But I mean, the question is out there for whoever would like to pick it up.
I can start by I can do this part. So yes, of course, it's a challenge. It's obviously a challenge. It changed a lot in the last couple of years, and it's changing at a very high pace. But on the other hand, this change also provides us with new tools. It provides us with an amazing amount, huge amount of information, a huge amount of new ways of doing things. So we opted to use these tools, understand their shortcomings, and try to find ways to use them in a different way, because everyone knows exactly the shortcomings, problems with transparency, the problems with consistency in the responses, the problems with people's trust. So these are things that we can jump in and try to find ways to solve them. And we are very functional in our way in our way to approach problems and try to approach new projects. We don't look at the technology, we look at how can we solve this situation. And this is another tool with a very big potential. So yes, it will steal us some customers, and for some very traditional services that we used to provide, for instance, consultancy. Right now, I think consultancy is going to have a very big decrease in search for it, because in demand, because people are looking at it in a different way, because they can have just ask online for a complete report and do it. I know for a fact that many people in consultancy at the beginning, when they found this, before the clients started doing it, they did it themselves. They asked GPT how to answer this, create a report for this, and then they use it, which is fine, which is a way to use their information, as long as you are critical about it, and then are able to use this tool uh, as a new tool. So it's an extra arm that we have to reach any solution. I hope I have answered your question. Sorry.
Yeah, from our side, if I'm to add something, what we discovered is that so in the way I see the world, there is USA and there is Europe, and we are moving forward on AI. But in the USA side, they are moving into like a very aggressive way, while on the Europe side, we care more about transparency, about being reliable, and so on. And this issue about um, is this technology that I'm using saying real information is very important, especially for media, for fact checking, for the areas that we are in. So even though we might use LLMs for infusion of knowledge and things like that, we still need to create a technology which is transparent, which explain itself, which helps them. And this is not something that there is so much competition in, because these more like neural networks, black box technologies are more developed, and we use them for very particular and limited tasks, but we like to give people the chance. And in how we navigate, so we talked a lot with journalists, and we discovered that even though they use the tool, it's not actually for them. It might be for bigger organizations. And we also started working on a new technology for them together with some journalists, which is more particular for them. And we are also going for bigger organizations to see if we have any luck there. So I think that once you get into the market and you start collaborating and better understanding what the other one needs, it's amazing, because we as tech people focus on technology and moving forward with technology, and we think about benchmark data sets and how to raise the accuracy with 0.3, while in real life it's not about that. It's about people and their needs. So on that side, I don't think that's so much competition as improving the benchmark, beating the benchmark with whatever percentage.
Thank you. We have two more questions in the chat box. The first one is for George from Video. When generating more images, after the user doesn't like the defaults, I observed you still included the first image, which he probably didn't like. How do you deal with this kind of issue, just in case the images are among the highly ranked?
So hi, Ivan. You're absolutely right. This was an example of bad UX practice. I mean, now the front-end tool just, in the demonstration, just loads more images. In the next versions, we skip this part. I mean, when you click load more images or new images, actually, the first 5 images disappear, and 5 new images appear to the user. The original thought was that we wanted to keep the images, all the images to the user, just in case he might like one of the 5 first images more than the second ones, and get back to the original selection. But in the evaluation studies that we performed, we observed that this was not the case. Actually, the case that you described in your comment was what actually was happening. So the users keep loading more and more images to retrieve the best fit ones.
Thank you, George. Then the next question is for Mindbug Discovery. May I know if there are plans to expand the data set of narratives beyond the US and Europe?
Right now, we are focusing heavily on Europe, and we are searching for partnership with one of the big networks of fact checkers. So we know that it's always up to date and it does not have bad data because of the scraping. So this is what we are focusing now, integrating with fact-checking networks. And if we manage to do that step, maybe in the future we will integrate with fact-checking networks from all over the world and from different parts of the world once we have all the systems set up in place. But right now, there is a lot to do in Europe. And in Europe, there are a lot of people who care about this and who invest in this and who try to combat this. So our focus is right now for Europe. But one thing I would like to mention is that even if there is a fact-checking organization in Europe, they are usually taking a look on propaganda from Russia, which is appearing in Russia, on propaganda which is appearing in China, and on propaganda which is appearing in these big other countries, which might affect us maybe sometime. So we are aggregating fact-checking in Europe, but this data also have some international characteristics to it.
Thank you, Ioana. A super short question on my side, and then we can. Oh, there is another. Again, I have one for Magnet, but also I'm going to first ask Ivan's question in the chat box, and then I'm going to ask mine. Are you planning on broadening your services, or you will only focus on law? So this is for Paulo. Paulo, I'm going to add up on this question so you can answer both. I also wanted just to ask you, how did you end up with this niche market lawyers instead of media? So just if you can tell us like 1, 2 sentences regarding this journey that you had.
Yeah. I I will answer your question first because it's very easy, completely by chance. They contacted us, we started talking, and it's this just fits exactly what we have been doing. So it was very easy. So it was completely by chance. They knew our work within this realm, so they contacted us. So and we saw this as a very good potential that we didn't even think about. With sometimes these things passes by and we don't look at them because we are not focused on that aspect. So we are planning on broadening our services, obviously, because we see this. We at this point we look at our tool not as a tool for journalists or a tool for lawyers or a tool for any kind of scientists. It doesn't matter. This is a tool for knowledge workers. And our idea is that with the huge amount of information that is available to everyone, we need tools that will provide them the most meaningful information within all the noise and all the redundant and all the irrelevant items that are there, and not only give them find them, but also provide them with meaningful information about them. Because for you to know that this interests you, you have to trust how it was found, why it's being considered, and how close it is. So it's not in the end. If you look at George's and the Joanna's presentations, we are all dealing somehow within the same dimension, which is providing a more trustful AI application, so that people understand what they are reaching, how the information that reaches them is useful and meaningful. So yes, of course, I see it applicable in many other uh, sectors, even in manufacturing. One of the first people that talked to us about this was an aircraft manufacturer who wanted to reach information about previous projects and requirements, and wanted to get just the necessary information for a new project. So this is something that I see very easily as a very horizontal application. Yeah.
Thank you. I think we had very interesting questions. Thank you for this part of the session. Now we're going to move to our second track, which is the research track projects. Here you see their abbreviations and their full names. We have Camouflage, Clip Lens, Elmer, HoloNext, and Vol. Since we have a bit more projects here, 5, I suggest for the Q&A session, once a question pops in your head, just mark the name of the organization that you want to ask, so it will be easier for you.
Good morning, everyone. My name is José Antonio. I'm from Centig here in Spain, and this morning I want to talk about the Clipland project. These are the topics that I'm going to talk about this morning. First, I will provide a short introduction describing the problem. Then I will discuss the work on activities, and I will continue with promotion activity, and finally, conclusion and future work. Okay, this project consists of two main parts. The first one is for generation of images, and the second one is for image labeling. The main objective is to mitigate the lack of data that may exist in certain domains, because this is a very common problem that many data scientists need to face in their daily work. And as a result of it, we can find some specific objectives, such as improve the prediction of clip model, design and develop a retraining pipeline for cases where out-of-domain or cross-media data is present. We need to merge these previous objectives to create a methodology, and finally, we communicate and disseminate all the results. Okay, in this section, I will explain all the techniques that we use in order to achieve our goals. We generate images for 3 use cases that was fair for clothes, professions, and objects. We combine Stable Diffusion with Dream Booth and LoRa technology. In fact, we compare of 3 versions of Stable Diffusion, version 1, version 1.5, and version 2.1. Briefly, I have to say that Stable Diffusion can generate images from given an input text. Dream Booth is generate different context for given images, And finally, LoRa improved the speed of the whole process. For evaluate our work, we choose two quantitative metrics, that was click zero shot and click score, and one qualitative metric that was a survey. Finally, we also test a clip-based tool that was a clip interrogator in order for labeling images. Okay, here there is an example of how each version of a Stable Diffusion performs. Particularly in this case, we asked the model for some images of doctors. The two quantitative metrics are shown at the right. At the top, we can find clip score, and then at the bottom, clip zero shot. Okay, then we conducted a survey in order to measure the quality of the images that we generated. We choose 30 participants, the half of whom well involved in artificial intelligence, and the other half well inexperienced in this field. And finally, the most of them agree that the Stable Diffusion version 2.1 achieved the more realistic results, followed by 1.5 and finally 1. Okay, about clip interrogator. Here there is an example about how this tool performs. Its function is to provide a description of a given image, and as we can see here, the description of that they give to us were very accurate. Okay, our promotion activity. We held a workshop last year. It was attended around 50 people from different companies that were related by IoT, artificial intelligence, and some of the attendants showed a lot of interest in incorporating this technology into their sector. Additionally, we are promoting all the project step on the scientific website, also on social network, LinkedIn, etc. Okay, finally, in order to conclude, to sum up, I have to say that Stable Diffusion 2.1 version achieved the best result. We improved the model accuracy in all the tested domain, clothes, object, and profession. And I have to say that the use of LoRa was essential in order to improve the speed of the model and reduce the cost of it. Now, nowadays, we have unlimited images for dataset, and also clip interrogator tool performs satisfactorily. And currently, we are working on first achieve photorealism, and second avoid biases due to English language prompts, because these are a topic that we want to carry out. And that's all from my side. If you have any question.
Thank you, José Antonio. Questions will come up at the end.
Okay.
Now, let's move to the next in line, Elmer.
Hello. Right. Let's do that. And do the screen. Let's do that. There we go. Is that okay?
Just a sec. Yes, full screen. Thank you. You can go.
Cool. Okay, great. Right. So, hi, I'm Andrew from the University of Surrey in the UK after our exciting election last night. Right. So, we're going to present ELMA, which is efficient long-term multimodal video retrieval. Go forward. So ELMA's overall goal was to basically create a content retrieval system which can handle multimodal data, especially for long data, which is like longer than 10 seconds or so in video. And to do this, we had three different objectives, but fundamentally the point of the project was to, given some text, for example, find me videos of tennis swings, it would happily go off and find some videos, often quite low quality, like what we've got here, because not everything's perfect by any means. And it would show some examples of some tennis swings videos. The idea originally was to use audio, visual, and text, but I'll describe later why audio was a challenge. The sort of main solution that we came to was a few-shot learning approach. Now, so given the example of locating a golf swing, we care a lot about sports, it seems, existing methods generally learn a single prompt to identify the location in class. So they just learn, show me where all the golf swings are in the videos. However, actually within videos, you can see that we have things like golf plus fairway plus trees. We've got golf plus swing plus backwards, golf plus hitting plus ball. Now these, to a human, all of these would be good responses for showing me a golf swing. And to do this, our approach aimed to basically learn some of these additional prompts, they're called text prompts, alongside the sort of just golf class, which was the original labeled class. And so here we can see that the green frames indicate the foreground features, the bits that we want, and we allowed our model to learn multiple prompts for the activities to cover the diversity of these retrieved videos. To do this, we get rid of this down here. It's a sort of multimodal approach where we've got our video features coming in. We've got our our text features. Now, importantly, our text features here this is the class, so golf or tennis, swing or whatever. But the really crucial part of our whole approach is that we've got a load of learnable prompts here, as well as our text, which will allow the model to learn the things such as fairway, such as green, such as backwards, etc. And so the model works by having the extracted features from the video and the extracted features from the text. Now, really importantly, with our approach, we used pre-trained foundational models, so CLIP, AI4Media. So rather than having to waste expensive compute, costly compute to get to train these kind of features, we're able to just use existing stuff. And by the time, and then later on, we use something called optimal transport, which basically is able to link our video features with our learnable text prompts that we've got, and then we can work out a similarity between them, and this allows us to locate these classes that we're looking for. Yeah, and like I said, importantly, only the bits with the fires are trained, and the rest is all kept frozen, which is really important for efficiency. And so in doing this, we can kind of see, here's an example of cricket shot, for example, and we've got 4 learnable prompts in this. And we can see that this sort of lighter blue color works really well when we've got these sort of big wide shots like here, and we've got here as well, haven't we? Whereas other prompts are sort of middling all the way through, and then this darker blue one works in between. So previous approaches would just have one of these learnt responses, which would mean that it maybe would miss some of the key parts that we care about, like these bits here. And so our approach instead was able to learn additional complementary views and create a sort of higher quality retrieval system. Now, being a university, the main point of this work was basically really, really low TLR research, and it's exciting new initial research. And so we submitted our work to 2 major conferences within computer vision and machine learning. So we got some of our work, this bit of work, accepted at a NEWIPS workshop back in just at the end of 2023, and then we put more recent work into ECCV just recently. So this is a really good output for the project, that in the 12 months we're able to get 2 high quality conference submissions. Obviously, also importantly, we basically told anybody that we could about our work, and so we were able to present our poster, which is here. We did some work with some invited speakers. We went to Northern Ireland, we went to Paris, we went to NEWIPS, I think, and able to talk to our work to other people. Really important. And yeah, we put the 2 papers into the AI4Media ecosystem as well, which was on the Zendodo website stuff. The team was multidisciplinary. Got myself as a sort of machine learning. We got a cinematographer involved, and we got Ed, who actually did he was doing the PDRA work, getting it all outputted. Looking forward, the initial plan for the project was actually to use audio dramatically within this work. However, we found that audio is actually very distracting often, especially in these kind of sports and broadcast footage, because the audio doesn't always correspond with what's going on in the video domain. And so we actually, for that sort of like finale work that we just showed you, we actually dropped the audio. And so going forwards, that would be the bit of work to do would be to try and get that audio back in there in some way. Overall, though, we're very happy with the progress and the sort of outputs that we generated from Elma, and are looking forward to taking it further forwards. Thank you.
Thank you, Andy. Excellent presentation. Now we're moving to the next one, which is Hello Next.
Hi. Okay, I will share my screen now. Wait a moment. Okay. Are you seeing it?
I just see the top bar. If
Yeah,
it's
I
possible.
think it's
If it's
in
not
Google
possible.
Docs. Yeah.
Okay. Okay.
So, oops, sorry. Yeah. So, okay. Yeah, basically, I am Ivan Huerta from Itucat, and I'm coming here to present the research project on X. I will start. So first, I wanted to show you now, the technology has allowed like new ways, to produce and consume media. There is like this new spin from the traditional flat video, and now you can use this chroma key, like for example, weather maps or graphics, as you can see in the video, where the presenter is transported, virtually transported these virtual environments. But what is the problem? The problem is that currently this immersive media that is produced, lack of volumetric natural content. The journalist that is presented there is presented as a 2D image instead of a 3D image. At the same time, there is all this cost of the computer graphic generated scenes, like to create all of the scenes that you are seeing, for example, in this video. And also in this case, for example, you have also all the equipment that you need, not this bulky and expensive production as the green screens, the cameras, the motion art. And overall, we have like this problem that it's the content creation. To create some content, you need spend a lot of money and resources. Also, it's not only for like this broadcasting as an example, but for any kind of immersive social virtual reality experience, for example. So then what we propose, or what is the solution that we are thinking? So basically what we wanted, it's Alonex, basically is the combination of two technologies. For one side, what we wanted is to create a new content like the scenes, like in more an automatic or semi-automatic manner. And for the other side, we wanted to allport, like the enable these volumetric live communications in a more immersive manner. So then in this case, we have these two technologies, new technologies, that for one side is like this modeling of the scenes, where we wanted to improve the nerves to create it more easily and accurate for photorealistic scenes models. And for the other, what we want is to create all of the research that we are working on holoportation inside of a transmission pipeline within the XR media production tool. But then how it works? So basically what we do first for the live content, for the allometric part, what we do is to capture the person, in this case myself, as you can see, with simple sensors as Kinect. And we can capture with one camera in this example, but also multiple cameras. What we do is later to create capture ourselves, created with these multiple RGB cameras, then integrated all of them to create a volume. This will be creating a point cloud that this point cloud, then later we will be compressing it from this 3D data to a 2D mapping. All of this will be encoded and transmitted, and then we will be decoding it in XR application, where later we will be rendering in this immersive scenario. You have to think all this receiver and decoder is integrated on the Unity plugin, so then we can also use Unity as a tool. this is for one side, and then for the other side, what we try it is to model a scene, like we capture some scene and to model it in less than 3 hours so that we can have this content in very real immediately time, no? And what we do is capture the scene, then later to model this scene with the nerve. So in this case, we have been improving the nerve-based 3D mesh reconstruction. So we have improved base models like NERV and RevNERV in order to work better when we have like this reconstruction for smooth and textured superfaces and adding some regularizations that to provide more consistent on the surface normals. As you can see here on where you are combining this live transmitted hologram, and then we have generated this, the offline as the one side or all the scene. So then let's see some of the results. So as you can see here, it is what it is created with this virtual TV studio, and in which I have been teletransported inside of this scene that we have modeled in less than 3 hours. Then you can see as this is natural content because we can be traveling, doing travelings with the Unity plugin that we have it. So we can move around all the scene. As you can see, it's a 3D scene, and also myself is a 3D, so it's a live content. So then we are being able to see this live content. So here is like reproduction, but instead it is working all in real time. And we can do more things, like for example, to interact in real time with objects that can appear or disappear in the scene, as we can show it on with the one side. So then, what is the market potential of all of these beer production tool? Well, it could be for media and for gaming industries, but basically the benefits is that then we have like this live volumetric natural content that it's in this case the anchor, no, the presenter, that was myself, and also this semi-automatic generation of the immersive content. No? What will be its benefit? Well, it's clear, no, that if you can generate this semi-automatic content like in a more fast way and accurate, it will be cheaper for all the production and the content creation. So then you can have more content creation. So this will be a better for an end user, because then he will have more content, and also as it is like 360, you will can have it, can see it with different points of view or different viewer options as headsets, tablets, smartphones. So then at the end, it could be much more immersive. So basically, the team that we have been working on this for the last year, it's a multidisciplinary team that we have experts in artificial intelligence, myself, but also experts in immersive technologies, as we have been demonstrated with the components. We work in the E2CAT, like it's a research center that it's with more 200 people, but it work in immersive technologies, but also in more technologies, as you can see here, and always open and collaborate. And to finalize, we would like to thank you to our monitor, Simon Almeida, that have been following all of the project, and thank you to them, and also to our coach for Stefano, for all his support and all his advices, and of course for AI4Media for getting this opportunity to do this research. And I finally will call for actions if you think that it's interesting what we are showing, so then put in contact with ourselves, because we are always wanted to collaborate only and to test our technology in all of the fields. So yeah, this is basically all. Thank you.
Thank you, Ivan. Yeah, very interesting presentation. Right now there is a call for another project which is dealing with something very similar that you have presented. So I'm going to share details with you to see whether you're interested potentially to collaborate there.
Okay, yeah, perfect.
Okay.
Thank you. Yeah, perfect.
Thank you. And then we're moving to the final presentation, which is Vo Evo. Do we have a representative for Voivo?
Yes, of course. I will just share my screen immediately. Anything?
Yes.
All right, perfect. So I'll just, my name is Marius. I'll just get straight to it. Our primary objective has been to generate collections, sets of images that are representative of volume data sets. So volume visualization is a well-established field of research, and there are many, many sources of volume data, the most prevalent of which is medical imaging. So this is why I'm exemplifying here with a medical CT data set. The data itself only contains raw values, and our task has been to generate sets of images that are representative of the contents of the data in a way that illustrates structures, features, anatomical properties of the data, and in such a way that the images are also diverse enough so that they don't repeat amongst themselves. So quality diversity images from volume data. So our solution is a system that has three main components that are interacting with each other. There are many technical details, of course, but basically we have a volume renderer, the component that generates images. We have a feature manager that determines certain criteria for what it means to have quality and diversity in the images and in the objects that are being processed. And we use an evolutionary optimizer to that formulates objectives from these features and that basically tells the volume renderer which images to generate. So one of the more difficult aspects of our work has been to define objectively what it means to have quality and diversity in our images. And we also wanted to do this image generation automatically without user intervention. And for this purpose, we use the quality diversity evolutionary optimizer. I'll just get right to straight to some examples. So what you're seeing here is the same medical data set, so a gallery of images automatically generated by our software from the same CT scan. Normally, the radiologist views individual slices, but we can represent it in 3D, and our software automatically deduces what it considers to be the best viewing angles and the best opacities, transparencies, colors, what are the most representative surfaces to display, how to illuminate, how to apply the illumination model, from which direction is the light source coming, the intensity of the shadows, how many structures to display, how to adjust opacities so that multiple structures are displayed simultaneously without creating a visual overload, and so on and so forth. This is obviously not applicable just to medical images. Here's an example from meteorology, from the environmental sciences. This is volume data from weather radar. What you're seeing is a hurricane, and we can, in a similar manner, we can generate various representations of this data where we illustrate various spatial features of the hurricane, what happens at different altitudes, and so on and so forth. And this is from data that contains humidity values. So the distribution of humidity values can be used to output visual representations of the hurricane, which can be used, for example, to assess the destructive potential and for hazard identification and so on and so forth. Here's another example. This is a industrial scan of an engine block. It's just an engine block data set, just two cylinders, part of an engine with two cylinders. The idea is the same. Our software attempts to search for the most relevant, the most meaningful. We use the word meaningful, but it's exactly the right word. The most meaningful representations for such data, anything from the angle to the light source, to the colors, to the opacity. The views are generated automatically. And we also tested it in a sort of more artistic direction. This is a bonsai tree, also a volume data set, so it's not a polygonal model, but it's a voxel data. And in the same manner, our software searches from the same data set for different views from different directions, what it considers to be a nice, high quality and diverse set of representations of the data set. Of course, this can be done manually, but at least for medical and industrial CT and climatology, it requires an expert, it requires some a priori knowledge and a specialized user interface. But in our case, this basically works at the press of a button. So there are many configurable parameters for our software, but in the simplest case, you just input the data set, press enter, you wait a while because it does take a while to deduce all this stuff, but it outputs a gallery of images automatically and directly. So these are a few examples of our work. We have a software prototype with full functionality, which is open source. We, of course, plan on extending it in multiple directions, such as right now, everything is completely automated and angles, lighting, colors, opacities, structures, surfaces, everything is determined automatically. But it would be useful to incorporate user feedback and to sort of steer the image generation in the right direction, or introduce some kind of supervised mechanism to do that. And the next logical step is that we want to generalize it to other domains, not just right now. Our objective has been to do this for volume graphics, for volume data sets, but the same is applicable in other directions. For example, in a more general sense, for the generation of content for entertainment and art. So it's not necessarily restricted to technical areas. So this is who we are. This is the team. We are from a technical university in a city called Iași in Romania, Faculty of Automatic Control and Computer Engineering. Here is myself and my team members showing a certain amount of reserved optimism. We each have our own specializations and dreams and desires, but we're all colleagues. So as far as collaboration is concerned, we are interested primarily in scientific research because our bread and butter is journal publications and project proposals and everything that our fellow researchers will have been familiar with. We don't completely discount the commercial exploitation of our software, but this requires a different type of discussion. It's a bit more elaborate. But so right now our software is open source, and from the beginning of our project, we intended it as such. The easiest way to contact us is through the email that you can see on this slide there, if you're interested in collaborating and expanding upon this type of stuff. So thank you very much for your attention. Here are more images of our work. And I'd like to congratulate everyone else for their projects. I thought they were really impressive achievements considering just this 9 or 12 months. I have to say that the work is phenomenal that I've seen. So thank you.
Thank you, Marius, for the excellent presentation. And I think this is the right place exactly for such type of collaboration. Here we have excellent researchers right now at the demo day, but also, as you know, through the AI on Demand platform and all associated partners of AI4Media, you can as well find such type of interesting collaborations that will suit your needs. So thank you all. Thank you all to all of the projects. Now we're moving to the Q&A session for the research track. Let me just share my screen very briefly and for the final time, and I want to open it on the research track project so you can know who you want to ask your question to. Okay, so now I don't see any raised hands, but I see the first question in the chat box, which is for Elmer. How is the video retrieval evaluated? Is there a standardized data set?
Yeah, cool. Yeah, so there's a few standardized data sets, including the one called Thumos, THURMOS, I guess, which is like one of the most popular ones. And that consists of a load of broadcast footage. And the way it's evaluated is it has two metrics basically. The first one is how good it is at localizing where the activity is occurring within the overall footage, and then how good it is at classifying that footage to be the right action class. And those two are the sort of ways that it's worked out to measure success.
Thank you, Andy. Next question is for HoloNext about the triangle in the demo at the subject's feet. Is it an artifact? Also, can the method work if the subject is moving? Would it increase the equipment cost? This one is for HoloNext. Ivan?
Sorry, yeah, I was in mute. Sorry, I was answering, but no one was listening me. So basically, there is a lot of questions. First, the triangle of the demo of the shooters feet is basically that there is like a little misalignment between like what will be the floor, and then what you see this triangle was like the capture of the floor. Because in this case we haven't used any kind of removal artifact, so then it could be like segmentation of the feet of the person, that will be avoiding this triangle. So that the method work if the subject is moving, yes, but you have to consider that what we have now, it's what you see it with one camera. So we are like reduced to the space of the camera. As we can use multiple cameras, then we can increase this volume space. But at the moment is what it will be some restricted space depending on the number of the cameras that you have. How the equipment cost? It's really very cheap. So you have to think that it will be only the camera, that it's a Kinect camera, or Kinect, or any kind of camera that gives you like the RGB and the depth, and also like the computer, like you are using as well with a GPU, of course, for the rendering part. But it is all. So then your production studio could be very, very, very cheap. And then, yeah, and I think that it's all for me. Great, thank you.
Thank you. And then a short one for Voivo. Are the created views evaluated for accuracy?
Oh, well, in terms of like an objective visual evaluation, we used the non-reference image quality assessment methods. But for a proper evaluation, what we did was we did a user survey. We did a user study, which is the proper way to evaluate such data, because we wanted to account for quality, and we had objective measurements of quality, and we used both image quality assessment methods and a user study to assess our work. That was these were the main avenues for evaluation.
Thank you. Do we have any other questions? Sam?
Yeah, so I can add my 2 cents here. So a question to our research projects. So several of you had the terminology exploitation or market potential. So the question to whoever wants to pick it up as well. After having done this work, have you thought about taking eventually the next step forward and shifting, pivoting, as we've heard about today, towards taking your research into a more commercial solution? I mean, even the last presentation from Marius, you mentioned the software. So you already have something that could be, wrapped up quite nicely, and looking for that opportunity, but not focusing necessarily on you, but to anyone who wants to answer. Do you see yourselves maybe participating in a similar project under an application track in the near future, and not so much from the research perspective? So open floor to anyone who wants to pick it up.
So there are several aspects that are of concern to, especially to people from the academia. When moving into a commercial avenue, the issue is there's always the argument when collaborating with SMEs and commercial partners. What is the border between what's an intellectual property and what can we publish? So this is one aspect of the problem. The other one is that it's one thing to develop a software prototype for research. Moving it to a commercial direction requires additional steps and a different kind of validation from just measuring accuracies and so on and so forth. It requires testing a different type of benchmarking and so on and so forth. The other issue is the available time. Do we want to take time away from our own tasks, such as teaching and publishing and research and so on and so forth? Can we devote time to developing applications for a commercial, in a commercial direction? So there's also the issue of, do we want to be do we have the time and the resources to keep both directions, both the research and developing a commercial product? So these are it's more than 2 cents, but this is sort of my dollar.
Thanks, Marius. Not sure if anyone else wants to add.
Paulo?
Sorry, I just wanted to ask, so if I completely understand your point, but I would also like to know, how do you envisage all your research being then transported and transformed into something that has a societal use, so some practical use in society? I understand you're not able to, but how do you see the links that will lead from your research to an actual application in the real world?
I'm not sure if that was a question for me directly or for anyone.
No, well, it was for you because of what you said regarding your work, okay? Because you said, and I understand you don't really have the time to go into this because you have your core business, your core tasks are different than this. But how do you envision? I imagine that everyone that does some kind of research wants to see it somehow then transported and transformed in something that is meaningful for the society. How do you see this happening?
I can give you an actual example. A while ago, I was part of a research project that dealt with volume graphics for medical data, and not everything that I did, but I collaborated within that project. But ultimately, the technology was ported to computed tomography scanners in hospitals. So it was a large project with a CT manufacturer, and ultimately the software that we developed. And again, there was this adventure and negotiation of what to publish and what should be an intellectual property, but ultimately it was ported to CT scanners, and at the time it successfully provided more comprehensive views of what was going on than just individual slices. So this is one direction. Strictly for what we did with Volleyball, one application would be in automated procedural content generation. So for example, in the gaming industry, procedural generation has been criticized. There were certain large-scale projects where game developers tried to use procedural generation for their game, and the initial release was a complete failure, and they were, I don't want to give concrete examples of AAA games, but there were highly publicized video games that attempted to use procedural generation, and they were badly received. Eventually, they changed many things and they resurfaced. So time and time again, procedural generation for the generation of for entertainment purposes has been criticized because it tends to be repetitive and for many other reasons. So this is another direction that we can take things into. Yeah, so these are at least 2 examples of the potential usefulness for our work.
Thank you. I don't see any other questions in the chat box, and we're exactly on time. Well, a bit more, but more or less. So I think we can close. Thank you all for attending. I just want to say that we are very proud of the projects that were part of the open calls, and we are rooting for you. We really hope that we will help have the opportunity to be collaborating in the near future. And that's it. You are going to hear from us either for pleasure or for reporting purposes, so stay tuned. And that's it. Have an awesome day and have a lovely weekend ahead. Bye.
Thank you.
Bye.
Goodbye.
Bye.
you.
Thank
Bye.
you.
Thank you very much, everyone.
Have a nice
Bye-bye.
day.